Let the EMFs of two given batteries be epsilon 1 and epsilon 2 respectively. The positive terminal of the first battery, epsilon 1, is connected to the terminal A of the potentiometer, and its negative terminal is connected to a sliding key, also called a jockey, through a sensitive galvanometer. This key is then slided on the potentiometer wire to find a point C1 such that the galvanometer shows zero deflection. This point is called the null point, and it is clear that the potential drop from A to C1 is equal to the EMF of the first battery. Let AC1 be equal to L1. Then using equation we get epsilon 1 is equal to epsilon into rho upon R plus L into rho plus R into L1. Now the first battery is disconnected and is replaced by the second, epsilon 2, and the corresponding null point is obtained. If C2 is the null point and AC2 is equal to L2, then epsilon 2 is equal to epsilon into rho upon R plus L into rho plus R into L2. Thus, epsilon 1 upon epsilon 2 is equal to L1 upon L2. To compare the EMFs of the two batteries, this equation is used. Length of a potentiometer wire is 200 centimeters. With a given battery, the null point is obtained at 80 centimeters. What will be the length at which the null point is obtained if an identical wire of 300 centimeters length were used? Neglect the internal resistance of the battery and take R is equal to 0. Solution: let the EMF of the battery which is being balanced be epsilon 1. Therefore, epsilon 1 is equal to epsilon into rho upon R plus rho into L1 plus R into L1. Now R is equal to 0 and R is equal to 0. Therefore, epsilon 1 is equal to epsilon upon L1 into L1, that is equal to epsilon upon L2 into L2. Therefore, L1 upon L1 is equal to L2 upon L2. Therefore, 80 upon 200 is equal to L2 upon 300. Therefore, L2 is equal to 80 into 300 upon 200. Therefore, L2 is equal to 120 centimeters.